Hi guys, this video is going to talk about how to graph systems of linear inequalities. So we've done linear equations and we looked at three different methods for solving: graphing, substitution, and elimination. We are going to use our graphing method for inequalities, but graphing inequalities looks just a little bit different. So we're going to graph each inequality like we would normally. So I'm going to graph each inequality in the system. Shade accordingly. So if you guys remember our inequality lines, the less than or greater than symbol is a dotted line, whereas the less than or equal to or greater than or equal to is going to be a solid line, and then we're going to shade either side of the line depending on which way the inequality is facing. So the intersection of our two different shaded regions is going to be the solutions of our system. And that's just one word, intersection. Okay, and then we can always check. We can pick a point in that shaded region to check and see if it's a solution. So just like our systems of inequalities, it has to work for both in order to actually be a solution. So we're going to just practice checking solutions here. So I want to check if -1, -3 is a solution to this system of inequalities. So I need to check the top inequality and the bottom. So I'm plugging in -1 for x and -3 for y. So I'm just checking that, is this true? So is -3 less than or equal to -3 times -1 plus 1? So -3 times -1 is 3. And -3 is less than or equal to 4. So it works in the top one. So let's check the bottom one. So now plugging it in here, so -3 for y. Checking, is it actually less than 2 times -1 plus 2? So there I get -2 plus 2 is 0. So -3 is less than 0, so it works in the bottom one as well. So this, yes, is a solution to our system. Try this guy. So we were checking -1, 5, so -1 for x, 5 for y. Check the top one. -2 times -1 minus 1. Okay, so here I get 2 minus 1 is 1. 5 is less than 1. That is not true, so this is not a solution. We don't even have to bother checking the bottom one, because if it fails the first one, it's automatically not a solution. Okay, so now let's use our graphing method here to solve the system. All right, so we're going to graph each inequality. So y is less than -x plus 4. So my y-intercept is 4. And 1, 2, 3, 4. And my slope is -1, so I'm going to go down 1 and over 1. And this is a less than, not less than or equal to, so it's going to be a dotted line through those points. All right, this guy, oh, and sorry, it's y is less than that. So less than is going to be below that line. All right, now we'll graph the second one. Y is less than x plus 1. So my y-intercept is 1. My slope is +1, so up 1 over 1. And this is less than or equal to, so it is going to be a solid line there. Okay, and it's y is less than, so now I'm going to shade below that line. All right, so we want the intersection of the shaded region. So I have this shaded region and this shaded region, and where they intersect is right here between those two lines. So those are my solutions. So then the last part was to check. So I would want to pick any point in the shaded region where they intersect, and I could plug it back into both inequalities and check. So let's just do one. Let's pick 0, 0, because that's a nice easy one. So 0, 0 is in that intersecting shaded region. So if I plug in 0, 0 into both of those, it should be true. So top inequality is 0 less than negative times 0, or -1 times 0, plus 4. 0 is less than 4, check. Plug in the bottom one, is 0 less than or equal to 0 plus 1. 0 is less than or equal to 1, that works. So that is graphed correctly. Sorry, shuffle here. All right. This guy, y-intercept of -2, and slope of 2, so up 2 over 1. And this guy is a greater than, not greater than or equal to, so we are going to do a dotted line, so I'm going to extend my pattern here to make it nice and accurate. All right. All right, and it's y is greater than that, so we're going to shade above that line. All right, the bottom one is not in slope-intercept form, so I'm going to go ahead and rearrange it. So I'm going to add 2x to get y by itself here. So I have negative y less than or equal to 2x plus 6. Divide everything by negative 1, and it's an inequality. When I divide by a negative, it's going to flip my symbol. So now it's y is greater than or equal to 2 divided by negative 1 is negative 2, and 6 divided by negative 1 is negative 6. So y-intercept of negative 6, 1, 2, 3, 4, 5, 6. And slope of negative 2, so down 2 over 1, so I'm going to go the opposite direction. I'm going to go up 2 and left 1. Up 2 and left 1. All right, and this is a solid line since it's greater than or equal to. And it's greater than or equal to, so we would shade above that line. And again, the intersection of those shaded regions is our solution set. I'm going to darken that middle section up a little to show it's where they intersect. All right, couple more here. Y-intercept of negative 4, slope of negative 2, down 2 over 1, or up 2 and left 1. All right, y is less than or equal to, so solid line. And shade below, less than or equal to. Okay, that's the top one. Y is greater than negative 2x plus 5. So positive y-intercept 5. Slope of negative 2. And this is going to be a dotted line. And it's shaded above. So here there's going to be no solutions because there's no overlapping of the shaded region. Notice that happened when we had the same slope and different y-intercepts. So this is no solutions. All right, I'm going to rearrange my equations here, you guys, to put them in slope-intercept form. So I'm going to subtract 3x. So I've got negative y greater than negative 3x plus 2. Divide everything by negative 1. Flip my symbol when that happens. Okay, so that's my top inequality. Do the same thing for my bottom one. I'm going to add 3x. So actually, that one's actually good. So negative 3x minus 6. Make sure, oh, not negative, I added 3x to both sides. Sorry, that eraser. All right, so add, so we got y is less than 3x plus minus 6, and then y is less than 3x minus 2. All right, so we have y is less than 3x minus 6, so negative 6, 3, so up 3 over 1. And this guy is dotted. And it's shaded below. And this guy, y is less than 3x minus 2. So negative 1, negative 2. Up 3 over 1 for the slope. So same slope again. This one is going to have an intersection though, because I'm also shading below on this one. So in between the lines is not a solution, but below this one, they're overlapping. So that one's maybe a little hard to see, but between those two lines is not a solution, but below that one are all my solutions because they are overlapping there. All right, our last problem here, we are given a system and asked to write, we're given the graph of a system, we're asked to write the inequalities that represent these graphs. So inequality 1 is right here. So it has a y-intercept of 0 and it has a slope of up to over 1. So that's going to be y and then 2x plus 0. And it looks like this one is shaded below, so it's got to be less than. And it's a solid line, so less than or equal to. So that's inequality 1. Inequality 2 also has a y-intercept of 0, and its slope looks like 1, 2, 3, 4, 5, 6, and over 2. So 6 over 2 is the same as 3 over 1, and it's negative. So negative 3x plus 0. This one is shaded below, but it's a dashed line, so it's just going to be less than. So that is the system of equations there. All right, that's it for the 6-6 video. Thanks for watching.